We have a set of 11 different integers, and we pick 8 integers from that set. Prove that with the correct operations, either adding, subtracting, multiplying, or dividing, we can always obtain a number that is a multiple of 1,155. Okay, 1,155 is a really awkward and weird and out of the blue number. Usually when I solve problems and they're really weird numbers, like this wacky one over here, then I usually use pigeonhole principle to solve problems like this. And this problem actually uses the pigeonhole principle, so we're going to do that. So let's see how we can obtain 1,155. 1,155, if you prime factorize it, is 3 times 5 times 7 times 11. We want to find a multiple of this from the 8 integers. So let's call those 8 integers A, B, C, D, E, F, G, H. We somehow want to arrange them so that we can get 1,155. So try thinking of it like this. We have A plus or minus B times C plus or minus D times E plus or minus F times G plus or minus H. This form is really nice because if you look, there are 4 terms right here, 3, 5, 7, and 11. And there are 4 here, 3, 5, 7, and 11. We can put 3 in here, 5 in here, and so on. So what we're trying to do then is make A plus or minus B a multiple of 3. And similarly, C plus or minus D a multiple of 5, 7, and 11. So in our problem, we can rethink of this as we're choosing 8 numbers so that when we pair them up, we can make a multiple of 3, multiple of 5, multiple of 7, and a multiple of 11. This way we can get a multiple of 1,155. So let's see how we can make all these multiples. So let's first start with the biggest one, which is 11. Let's start with this one. We originally have 11 different integers. That means those 11 different integers can have a remainder 0, 1, 2, all the way up to 10 when you think of mod 11. And since we have 11 different integers and 11 different remainders, we can't pick 2 remainders that have the same remainder. That means we can't find 2 remainders where we can subtract it and get a remainder of 0 when we divide it by 11, which means that we have to find 2 numbers that have different remainders. And when you add up the remainders, it adds up to 11. For example, if you think of these numbers G and H, say that G is 3 mod 11 and H is 8 mod 11. That means if you add G and H, it's 11 mod 11, which is 0 mod 11. And that means that G plus H will be a multiple of 11. So that's what we're trying to find. And that's good because we have these 11 remainders and we're assuming that none of them are the same, which means we can always find pairs like this. It can either be 3 or 8, 4 and 7, it can be 5 or 6, and so on. So that's good. So we got the multiple of 11. So now we move on to the multiple of 7. So let's think of that. Because we already took 2 numbers from 11, we have 9 numbers left. So just write that down, 9 numbers left. And let's think of those 9 numbers as mod 7. You can have 0, 1, 2, 3, all the way up to 6. That means that when you pick 2 numbers from here, since you have 9 numbers, you will always have 2 of these remainders which will be the same. So that means, for example, then E and F, we can pick 2 numbers that have the same remainder. Let's just say E is 3 mod 7 and F is 3 mod 7. Then when you subtract those, it will be 0 mod 7. And that means that E minus F will be a multiple of 7. So we got that again. And we do the same thing for 3 and 5. For 5, we have C and D, which means that since we already took 2 numbers from here, so we now have 7 numbers left. And we're trying to get a multiple of 5. So we have remainders from 0 to 4. Which means we can always pick 2 of them so that we can find 2 of them with the same remainders. So similarly, we can make C minus D congruent to 0 mod 5. So that means we can create 2 numbers that is a multiple of 5. So we do the same thing with 3. Since we had 7 numbers left, and we used 2 to make a multiple of 5, we now have 5 numbers left to make a multiple of 3. So it's the same principle, it's the same pigeonhole principle, and we can get a multiple of 3. If we can get a multiple of these 4 numbers from the 11 numbers, that means that it is possible to make a multiple of 1155 from as said in the problem right here. So the principle we used here was remainders and the pigeonhole principle. And if you want to try a similar problem, here's a similar problem that uses exactly the same idea. So I'll just write the numbers down for you. We have 12 different integers, and we pick 8 of them. And the rest of it is the same, and prove that you can always obtain a number that is a multiple of 3,465. So here's a good exercise for you to try. Thanks for watching our videos, and if you have any questions or comments, please let us know at Math Express. Happy learning!